In this video, we'll look at how to solve percent problems, and we can use proportions to help us solve them, or we could write equations. And another thing is, when we're looking at problems dealing with percents, lots of times it is helpful to think about identifying the part in the problem, the percent in the problem, and the whole in the problem. Sometimes, not always, the part will sort of be connected to that word is, and the whole will be connected to that word of, and we'll see some examples of how we can do that. So here's an example of a problem. A dress shirt that is normally cost $38.50 is on sale for 30% off. How much do you save? For this one, I'll do the equation. So I'll show you how we can do this with the equation. So really what this question is asking is, what is 30% of $38.50, right? That's the original cost of the shirt, and you know you're going to save 30% off. We're trying to find out how much we save. So this is the total amount. That's the whole in the problem. The 30% is definitely the percent in the problem, and what I don't know is I don't know the part. So I could write this equation: part is equal to the percent times the whole. What I don't know, the part, is equal to the percent, 0.3. I'm going to change that to a decimal when I multiply by percent, times the whole, which is $38.50. And when we multiply that, we find out that that's equal to $11.55. That's the part. So you're saving $11.55 because that represents 30% of $38.50. All right, here's another example. 125% of what number is 17.5? So again, let's try to identify the percent, the part, and the whole, right? This is definitely the percent here. We're told it's a percent of what number? That keyword of kind of points us to the whole. So 120% out of what number? That's the whole, is 17.5. 17.5 represents 125% of something. So that 17.5 is the part. So let me use the proportion so you can see how to solve it with that. Part over the whole, so 17.5 over what I don't know, that's my variable, is equal to the percent over 100. So I'm going to put 125 over 100. Notice I don't put a decimal in this percent because 125 over 100 represents 125%. So I'm going to solve this proportion by cross multiplying. W times 125 is just 125W, and 17.5 times 100 is 1,750. To find out what W is, I'm going to divide both sides by 125. And I find out that W is equal to 14. So 125% of 14 is 17.5. And that makes sense because 17.5 is bigger than 14 and 125% is greater than 100. Okay, here's one for you to do on your own. Let's identify the part and the percent and the whole. So it says what percent. So that's my variable. My percent is going to be my variable, what I don't know. Of 56, that keyword of is pointing us to the whole. 56 is the whole, and then is 42, right? What percent of 56 is 42? 42 is the part. Again, that keyword is pointing us to the part. So let's see how to solve this with a proportion first. Part over whole, so 42 over 56 is equal to percent, that's my variable, over 100. I can solve this by cross multiplying, or I could recognize that 42/56 could be reduced. 14 goes into 42 3 times, and it goes into 56 4 times. If I multiply 4 times 25, I get 100. So I can multiply 3 times 25, and I find out that n is equal to 75. So 75% of 56 is 42. That makes sense. Our answer is 75%. But let's see, in case you solve this with a equation, let's see how you would do it that way too. So what percent of 56 is 42? My part is 42, so part is equal to the percent n times the whole, 56. To isolate n, divide both sides by 56. 42 divided by 56 is 0.75. So we know that my percent is 75%. All right, and then another place that that percents come up a lot is in like finances and things like interest and stuff like that. So let's just look at what's called the simple interest formula. Now, this is not what's generally used, but we need to understand simple interest before you learn about compound interest later. So interest is just the cost of borrowing money. Now, the amount of money that's borrowed or the amount of money that's loaned, we call that the principal. The rate, right? That's the interest rate, how much interest you're being charged. It's given as a percent. Sometimes you hear in car commercials, right? And you hear about an interest rate for a car loan or something like that. And then time is how long the loan is for, how long you're borrowing money for or lending it out for. And we've got this formula to help us find the interest. We multiply the principal times the rate times the time. So how do we use this? How much interest, okay, that's my variable, the interest, do you pay on a $12,000 loan at 6.5% for 5 years? Here's the loan amount, that's the principal. Here's the interest rate, that's my rate. And it's 5 years, that's my time. So interest is equal to my principal, 12,000, times my rate. I'm going to change that to a decimal when I multiply it, 0.065, times my time, which is 5. This is going to tell me how much simple interest I pay. So when I multiply all of this together, I get $3,900. That's a lot of interest to pay. So if I was to borrow $12,000 and my rate was 6.5% and I paid it off in 5 years, I would pay $3,900 in interest. That is a whole lot, right? That's not a good deal. All right, here's one for you to try on your own. You paid $1,200 in interest on a $15,000 loan for 3 years. We want to find the interest rate. So let's identify what we have here. You pay $1,200 in interest. That's your interest you pay. This is the amount of the loan, so $15,000 is the principal. You know you borrowed for 3 years, that's the time. It says find the interest rate. This is my variable. This is what I don't know. I don't know the rate. So I can use my formula. Interest is equal to principal times rate times time. 1,200 is equal to 15,000 times the rate, which I don't know, times the time, which is 3. So I know 1,200, I'm just going to simplify this, 15,000 times 3 is 45,000 times the rate. I can isolate R by dividing both sides by 45,000. And if we divide 1,200 by 45,000, we find out that the interest rate is 2.6 repeating percent. That's going to be my interest rate. You get a decimal, you got to change that decimal to a percent. And that's how we work with percents.